Have you ever paused to ponder the importance of Pythagoras' theorem in our lives? It's more than just a mathematical concept learned in school. It's a fundamental principle, a cornerstone upon which much of our modern world is built. The theorem is a silent partner, guiding countless fields such as physics, engineering, and computer science. It's the invisible hand that shapes the world around us. Look at the skyscrapers piercing the heavens or the bridges spanning vast rivers. They owe their existence to this theorem. But it's not just about grand structures, it's also about the little things. Ever wondered how sailors navigate the vast oceans, or how sports teams devise strategies? Pythagoras' theorem is at play, ensuring that each decision, each direction, each strategy is mathematically sound. From the architect's blueprint to the athlete's game plan, the theorem is omnipresent. So the impact of Pythagoras' theorem reaches far beyond the classroom, permeating various aspects of our everyday life. Now, what exactly is this Pythagoras' theorem we're talking about? Well, let's dive in and find out. Picture a right-angled triangle. It's a triangle with one angle that's exactly 90 degrees. This triangle has three sides, each distinct and important. We call the longest side, the one opposite the right angle, the hypotenuse. The other two sides are known as the perpendicular and the base. Now, Pythagoras' theorem describes a fascinating relationship between these three sides. According to this theorem, if you square the length of the hypotenuse, that's the same as squaring the lengths of the other two sides and adding those squares together. Imagine it like this: you're painting squares on each side of the triangle. The square you paint on the hypotenuse will always be the same size as the two squares you paint on the other sides combined. No matter the size of the triangle, this rule holds true. It's a simple law of geometry that's as unchanging as the North Star. Let's put it into words. The theorem states, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is the essence of Pythagoras' theorem, but why does this matter? Well, this relationship is at the heart of so much in the world around us. From architecture to navigation, from computer graphics to satellite communication, Pythagoras' theorem has a wide range of applications. So the next time you come across a right-angled triangle, remember this simple rule. The square on the hypotenuse equals the sum of the squares on the other two sides. It's a cornerstone of geometry, a fundamental truth of the universe that's as applicable today as it was over 2,000 years ago when Pythagoras first formulated it. In essence, Pythagoras' theorem is a simple yet powerful mathematical relationship that governs the geometry of right-angled triangles. But how does this theorem translate into a mathematical formula, you may wonder? Well, let's dive right into it. The formula of Pythagoras' theorem is as simple as it is elegant: a2 plus b2 equals sine c2. Now, don't let the squares and the letters intimidate you. They are just placeholders, waiting to be filled with the lengths of the sides of a right-angled triangle. Let's start with a and b. These two represent the lengths of the two shorter sides of the triangle, also known as the legs of the triangle. It doesn't matter which side you label as A or B, the theorem works the same way. These could be any lengths from 2 centimeters to 200 kilometers, as long as we're talking about a right-angled triangle. Now, on to CE. This is the big one, the longest side of the triangle, also known as the hypotenuse. It's the side that's directly opposite the right angle. If A and B are the legs holding up the triangle, then C is the slide that connects them. So how does the formula work? Well, if you square the length of side A and then square the length of side B and add those two numbers together, you get the square of the length of side C. Hence, a2 plus b2 equals sine c2. It's like magic, but it's not. It's mathematics, and it's been tested and proven for over 2,000 years. It's like a universal truth, a fundamental law of right-angled triangles. This formula allows us to find the unknown length of a side in a right-angled triangle as long as we know the lengths of the other two sides. It's a tool, a guide, a key to unlocking the secrets of right-angled triangles. So remember, a2 plus b2 equals sine c2 is the key formula that encapsulates Pythagoras' theorem. It's a simple equation, but its implications are vast, and its applications endless. Keep it in your mathematical tool belt, and you'll be well equipped to tackle any right-angled triangle that comes your way. So, what are the key takeaways about Pythagoras' theorem? Well, let's dive right in. Pythagoras' theorem, named after the ancient Greek mathematician, is a fundamental concept in geometry. It's a practical tool that helps us understand the relationship between the lengths of sides in a right-angled triangle. Remember, it only applies to right-angled triangles. That's a triangle with one angle exactly equal to 90 degrees. The theorem states that in a right-angled triangle, the square of the length of the hypotenuse, that's the longest side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. In simpler terms, if you square the lengths of the two shorter sides and add them together, you'll get the square of the length of the hypotenuse. This brings us to the formula, a simple, elegant equation: a squared plus b squared equals c squared. Here, a and b represent the lengths of the two shorter sides, while c always represents the length of the hypotenuse. It's crucial to remember this order, but why is this theorem so important? Well, Pythagoras' theorem has a multitude of practical applications. It's not just theoretical, it's used in various fields including physics, computer science, architecture, and even in GPS technology to calculate distances. It's a cornerstone of trigonometry and integral to our understanding of the spatial relationships that shape the world around us. And while it might seem complex at first, with practice, it becomes second nature. The beauty of Pythagoras' theorem lies in its simplicity and its universal applicability. It's a testament to the power of mathematics to describe and predict the patterns of the universe. So, to sum up, Pythagoras' theorem is defined for right-angled triangles. The formula is a squared plus b squared equals c squared, and c always stands for the hypotenuse. It's an essential tool in mathematics, and its applications are widespread and significant. Pythagoras' theorem, a fundamental concept in mathematics, continues to shape our understanding of the world around us. So, what makes Pythagoras' theorem so enduring and influential? Well, it's its simplicity and universal truth that have made it one of the most famous theorems in mathematics. With just three sides of a right-angled triangle, Pythagoras' theorem reveals a profound truth about the nature of space and shape. This theorem isn't just a dusty old relic of the ancient world. It's a living, breathing part of modern mathematics, science, and technology. From architects designing buildings to NASA plotting the course of interplanetary spacecraft, Pythagoras' theorem is at work. It's even in the technology we use every day, like GPS and digital images. Its enduring relevance is a testament to its power. But perhaps more importantly, Pythagoras' theorem is a testament to the human spirit, to our relentless curiosity and our drive to understand the world around us. The legacy of Pythagoras' theorem stands as a testament to the beauty and power of mathematical truth.